in part C. That's what's gonna help us find our C value. A, is the bird, oh here, this is what they start us with. dB dt is equal to, was it 1/5? 100 minus B.
I like your note of, you may wanna show the values.
Yeah,
First.
because you were like, yeah, one's bigger than the other.
It's, I thought you.
By the way, that would have been worth, I'm trying to remember how they worded it, but you had to, they just, the way they worded it, they said, uses the derivative, which you did technically do. It would just be nice to show what those values actually are. Is a bird gaining weight faster when it's 40 grams or 70 grams? Explain your reasoning. And all I'm gonna do is plug 40 in for the baby's weight, the baby
I
bird's
did plug
weight.
it in, and after I answered, I was like,
This
is
is
this
that easy,
Do it?
yeah.
Guess how heavy
So
these
40
birds
and
are.
Well,
70
it's
in
gotta
for
be,
this.
there's no other way.
Who cares how heavy these birds are and how fast they can move?
Okay. dB dt when B is equal to 40 is 1/5 of 100 minus 40. That is 60, 60 over 5 is 12. So what that means is when the bird weighed 40 grams, he was gaining weight at about 12 grams per, what's my T? Days, about 20 to 12 grams a day. It's a hefty little eater there. When he weighed 40, all right? dB dt at B equals 70, 1/5 of 100 minus 70, 30 over 5 is 6.
I'm guessing that 100 is their final form.
100 is in this case would be what's considered the max weight, yeah.
Like that's as fast as they get.
Right. By the way, this question, I wish Sloan were here for this one, because this is a BC, technically a BC level thing. This form is what we call logistic growth, and you could have looked at this and said, okay, 100 is going to be the max weight, because after that you're actually losing the weight. If it was bigger than 100, which makes sense. If it's smaller than 100, he gains. If it's bigger than 100, he loses, so that it actually equalizes to 100.
So it's horizontal tangent.
Yes. Horizontal
Horizontal
asymptote,
asymptote,
yeah,
yeah.
horizontal asymptote. Excuse me. Okay, so faster at 40. Because I would say dB dt at B equals 40 is greater than dB dt at B equals 70. Most of y'all
What's
did,
that word?
huh? 2 points. One for using the derivative and then one for your conclusion. By the way, this is not the way most of you would have said it. Most of you would have said, you know, because 12 is bigger than 6, which is technically right. You're using your dB dt. Your 12 is bigger than 6, then he's gaining faster at 40, which is fine. This is super fancy pants. Remember that.
So,
B is easy. Let's skip that.
No,
okay.
and then
It's not right.
Okay.
Uh,
Find.
okay.
I skip everything except for.
Number 1, find the second derivative of B in terms of T. B.
In terms of, yeah.
Okay, so they basically want me to take the derivative of this. So we have dB dt is equal to 1/5 100 minus B. Look at this.
See.
B is the name of the function and T is the variable. Fine. So the second derivative of B with respect to T, 1/5, what is the derivative of 100 minus B? Well, the 100 goes away.
Negative dB.
Negative 1 dB dt. Good. Negative 1 dB.
I think what really trips you up is the in terms of B,
Yeah.
which makes you, it throws in your head B is variable. You know it. You look at it, you're
Right.
like, no, it's not. It's dB, but then it's like in terms of B, which normally makes you think in variable.
Okay, in this case, when it says in terms of, just think this is the only variable-like thing I need to see in the problem.
variable-like thing without being
Right.
variable.
It is technically a variable, it's more like a parameter is what we call it, but it's kind of like a variable. So, I'm almost right,
Almost.
because I haven't put it in terms of b. Negative 1/5, that's easy. All I, God, there's another way.
Wait a
I don't
second.
want
Oh,
DBT.
1/5.
Oh, look at that. There's B.
So it's this is pretty much implicit.
This is exactly what it is, because that's what dB was. So dB dt, second derivative is going to be negative 1 over 25 times 100 minus.
Okay.
Now, use that to explain why this graph cannot resemble our situation.
Because that's not how it works.
Good answer, good answer. That's not how it works.
How many points do you get for that one?
All of them, you get all the points. Because it doesn't demonstrate the graph. That's not that. It's obvious.
Isn't it?
Mm-hmm.
That is technically what happens to, that's a lot of population model. Think about this, when you're real little, you tend to blow up pretty quickly. You're gaining a lot of weight each year, you're growing every single year, until there's a point, I don't know, early high school where it starts to level out, and then in your early 20s, you've peaked out. So this very much resembles a model, growth model.
I don't know.
Not this one, why not?
Okay,
Did they label this graph?
Days and weight.
So weight,
so let's see. So from
which for us, weight is B,
yeah.
and these are days.
Or time.
Or- So the problem really is at good old 1, yeah, that should be concave up. That's concave down. It's saying.
Okay. Look at what would happen if I used all these B values between 20 and 100.
They're all negative. This whole graph should be
Okay.
concave.
Yeah.
If this is between 20 and not quite 100, then this part will be positive, which means this part's negative. Okay, so the whole thing would always be negative.
So it'd be
Or-
easy.
This is not how it works.
Okay, what does the second derivative represent for us?
Concavity.
Concavity. And if the second derivative, concavity, is always negative, then we should be concave
Down.
down.
The whole entire time. It
And
should
there, right, the entire graph should be concave down, so this graph should have done like that.
be until you
Okay.
got
But
past
there-
100.
Well, it wouldn't, it would just level off. You can still be like that and always concave down. You just don't ever hit 100, you keep growing, but you never hit 100. That's what an asymptote is.
But I can always put something higher than 100.
No. You're thinking,
The bird never weighs more than 100.
right, okay, again, you're thinking of that, but for the, for the picture we've got drawn,
Yeah.
they did not go over 100, which is, again, something else that we couldn't have. The thing is, we'd never be able to, here's why we can't go over 100.
It would change the.
Okay, what if I actually hit 100? Okay, in order to get from
Yeah.
99
You increase by
grams,
0.
right, in order to get from 99 grams to 101 grams, I have to go through 100. But at 100, what's my growth rate?
0.
0, which means I could never get above 100. So there's no way this graph should ever be above
The bird never
I'm just saying,
reaches
if
over 100.
B-
Okay.
I know.
It's a tiny bird.
Okay. Here's why. You should have mentioned concavity, that you got a chunk of this graph that's concave
Well,
up,
this would be actually-
But it all should be okay.
and it should all be concave down. By the way, concave down when your B value is between 20 and 100, which is what this graph
There's
is.
that one bird that's born at 100, and he's going to screw the entire, 100.
Yeah, he's a hundred,
Yeah, he's going to screw the entire formula.
poor mother trying to get that egg out.
God. What kind of birds are these?
I don't know.
Oh, and grams. I thought it was.
No, teeny tiny.
What did you think? Pounds?
Right? Holy crap, that's what.
I was thinking like.
I'm thinking
ostrich.
ostrich, yeah, even they're not that big, I don't think.
They could be 100 pounds easily.
Can it?
Not out of the egg.
Yeah.
Not out of the egg.
I mean, but at a max size bird, 100 grams for an ostrich, for max size, that seems reasonable.
Graham.
100 grams?
No,
100 grams for
100 pounds.
Pygmy.
100 pounds for a full-grown ostrich is
That's
reasonable.
way undershooting it.
Yeah.
Yeah.
Ostrich
are
is
heavy.
200 easily.
You know how big those things
They're
are?
massive.
I weigh almost 100 pounds. You know how big those things are?
No, I don't actually.
They're big.
They're huge.
I don't know what.
They're
Go to
like
the,
grams
go to
over
the zoo.
here.
I've never-
Ride an ostrich.
I've never stood next
You
to an
can
ostrich.
ride them. They're that big.
I don't know that. I'm
Why
sorry,
don't you know this?
I don't know this. How? Why do you want to know this? I'm sorry, I don't know. My ostrich knowledge is
Yeah,
not.
all right, let's do some more math, this is fun, good. But go look up an ostrich and see how much you weigh.
God.
All right, C, use separation of variables. Oh, okay, so we're basically gonna find the actual equation here. Got it. I was disgustingly amused at the way y'all chose to separate your variables. I thought this was hideously. All right, it's not wrong. Some of y'all that got to this one and kept on going with it and tried to separate the variables, kudos to you, but man, did you make it way harder than what it needed to be. So here, what else did they say? B of 20, or I'm sorry, B of 0 is 20?
Yeah.
Is that right, B of 0 is 20? Okay, so this will come later when we're finding the plus C. Let's do this first. Separate your variables.
Okay. So, times dt on
Yeah.
one side
dt over there.
and divide by all that.
Not all of that. I would, this is what
Just
made
the
it,
100.
just the 100 minus B. We can't separate these two from each other, but I can at least keep him over there. And this is the part that made it a little bit more difficult for some people. It's not wrong if you use the 1/5. You'll get to the same finish line, it'll just be ickier mathematically doing it that way.
Because you had to do a really weird use.
Well, not you, you'll just have stuff hanging outside your variable that you're gonna have to, or outside your function you'll have to bring over again. This is probably the smartest way to do it. So, 1 point. All right, now, this is when we start racking up points, hopefully.
Points.
1, there we go. Antiderivative. 2. Anybody recognize that? No, nothing yet, you actually have to take the antiderivative first. By the way, since this was a 5-pointer, both of these antiderivatives together were only worth 1 point. It is a natural log.
It's
I
a
got that
fancy
right.
Here's the thing though, what would U be? It's a use of.
the entire thing.
100 minus B, so what's du?
-1.
Negative 1 dB dt, which a lot of people forgot the negative. So this is going to be the negative natural log of 100 minus B. Because of that right there, you get an extra minus sign.
Nice.
Okay?
That's how I messed up.
1/5 T plus C. Okay, looking good. That's worth 1 more point. If you got both of these right, that's worth 1, and then the plus C is a point.
I got
Okay.
Why is it every
C,
single one we do, it always ends up with like a natural log and then.
It's fun that way.
Like every.
A lot of them do, because these are, a lot of these setups are growth models, and growth models use exponential.
And we should.
This is what happens, why we have a log in the problem, because our answer is exponential. Okay, let's find, C. So, do some scratch work here. Negative natural log of absolute value of 100 minus 20 is equal to 1/5 of 0 plus C, gone. That's 80, so negative natural log of 80
Number.
is equal to C. It is a number, but it's a very important number. So we're at negative natural log, absolute value of 100 minus B is equal to 1/5 T minus natural log 80. Okay, I'm thinking the negative, so natural log of 100 minus B is equal to natural log of 80 minus 1/5 T.
Yep.
Just -1 across the board there. Get rid of this with an E. So we get absolute value of 100 minus B is equal to Okay, how many steps can you handle in one?
Depending on the person, probably.
Okay, this you would technically split into e natural log of 80, 8t, times e to the negative 1/5 t. E to the natural log cancels, so you get absolute value of 100 minus b is equal to 80 e to the negative 1/5 t. Then we move the absolute value out of the way, so we're gonna get 100 minus b is equal to plus or minus 80 e to the negative 1/5 t. Bring over the 100. Negative b is equal to negative 100 plus or minus 80 e to the negative 1/5 t. Then bring the negative over. So what happens here, this becomes a positive 100, and if you take plus minus and make it minus plus, it's still plus minus.
I want the sign to be green.
By the way, plus minus and minus plus are two separate things, so minus plus is different than plus minus.
What's the difference?
The biggest, let me finish this one, I'll show you. So now what we have to do is decide which one it is. If we stick in 0, we need to get out 20. All right, 0. Either the 0 is 1,
It's a positive.
is that right?
Yeah.
No, we need
Positive.
negative.
It needs to be negative, because we need this to be 20 as a final result, so we're gonna use the negative one. So b of t is equal to 100 minus 80 e to the negative 1/5 t. Let me also, yeah, let me point out, up to here, you've gotten 3 of your 5. Okay, in this short step right here, separate antiderivative plus c, that's 3 out of 5. Find c, one more. Last point. If you are strapped for time, skip that last one and come back to it if you got time. Okay? This, we know how to do it. It's just every single line you write, that's one more chance for you to make a careless mistake, and I would hate for you to burn that time on one point when you could have moved on to the next question. And I'm not saying don't do it, I'm just saying, if you got the time, great. If not, don't feel bad about skipping one point. You'll live.
1 point is not worth 20.
Not worth, okay, if the next question in line was an area and volume where I can bank some points, I'm on it. Here's where we use the plus minus versus minus plus, usually in formulas. I don't know how familiar you are with factoring, but if you were to factor a cubed plus or minus b cubed, it's a pretty famous formula, one we use a lot. This factors into either a plus minus b times a squared minus plus ab plus b squared. It's really two formulas rolled into one, so you would read it either across the top or read it across the bottom. A cubed plus b cubed is a plus b times a squared minus ab plus b squared.
So you either read the top parts or the
Or
bottom.
you read it across the bottom. So it does matter what order. If it's standalone, it doesn't really matter, but if it's part of a bigger picture, then it does matter.
Because you keep going with like plus minus plus.
Right, and then
plus
this,
minus
yeah, this one
minus.
flips over with that one. So that, there is a separate symbol called minus plus that is for that, which has nothing to do with this problem.
It could.
It could. So of all, I would say this B should have been tricky. I didn't expect anybody to do well on B at all. I figured y'all would treat this like it was a T and do something silly with it, all right? I fully expected you to get A right, and I fully expected you to get, honestly, 1 point for this and 1 point for C. I thought y'all would have screwed up this negative because you didn't do that with the U sub thing, which would have been, I don't know, you could have gotten a C from that, but I figured y'all would have messed up the natural. I thought this one would have been worth 2 points.
Well, I got my force points.
2, this, 2 is what I was banking on, 4 points out of this one. If you got any more than that, then you far exceeded what I thought you were going to do at this stage of the game. If this were an AP question in the next 6 weeks, then you better get all of them right. All right, last one, number 6.
Just for you, I had to look up the ostrich string. An average male weighs 254 pounds, and an average female weighs 245, and this is the comparison of a
Okay.
human and an ostrich.
I always see someone write an ostrich for a Halloween costume, so I'm sorry.
seen it in some movies, like the old Robinson Crusoe.
It was in the
You know what I mean?
blended movie,
I've seen it in Venture.
little
Yeah.
kid
Ace
and
Venture,
action.
But it's a kid riding the ostrich.
Yeah, and so you don't, like, I think it's like just small kids.
It was Adam Sandler too, or Hero.
Yeah. Not for
I know in
very
Ace
long,
Venture
yeah.
they did, but it was the kid, and it was like young Ace Venture did.
All right, last one. Let's see, 6. For 0 to 12, a particle moves along the x-axis. The velocity of the
Oh, I missed that,
particle.
so bad.
Shh, you shouldn't.
I shouldn't have. I
The
didn't-
velocity of the particle at time t equals 0 is given by. All right, so from
Oh,
6,
yeah.
here's our
I'm the only
info.
one that did it.
V of t is cosine of pi 6t. Right. Cosine of pi 6t. And the particle is at position -2 at times 0. All right, so at t equals 0, x equals -2. This is position, which means the antiderivative of velocity is going to be x of t in this problem. All right. What was the other time frame they gave us, 0 to 12? All right. I don't know if that's important or not, but we may as well write it down. All right, so here's the preamble, part A. When is the particle moving to the left? All right, talk to me about left.
What?
What do you do?
Take it, oh wait, so yeah. When that's negative.
Okay, so we typically, and I like how you didn't say take a derivative. We take the velocity, which they gave us, set it equal to 0 to find the stopping points, or critical numbers, and then test in between there. Gotcha. So I'm going to say v of t, which is cosine of pi 6t, is equal to 0. By the way, how many times have we seen that be worth a point? Just writing that down, that v of t equals 0 is worth a point. When
There you go.
t equals, okay. Probably need to do some more arithmetic with that. Okay, so talk to me about this. In order to get, okay, say the arc cosine, so pi 6t will be equal to the arc cosine of 0, which is pi halves.
You do it this way.
What did you do?
I said, well, cosine, third and fourth quadrant's negative, so. Oh, no, it's the second and third quadrant's negative, so from there, and then there.
Right, and then you had to find the actual t value that made that happen.
So I took that and I just plugged in random, I'm like, okay.
You
so-
guessed, right?
No, like, you take that and then you plug, so
Yes. You get.
pi over 6t equals those two, and then bam.
All that cancels. Cancel, you get 3. So the first time that happens is 3.
Yeah, I did that.
Okay, and then we do it again. The next time it happens is at 3 pi over 2. So then we multiply that by, so I think we get 9.
Yeah, because 9, but.
And then the next time is 6 more than that, so 15. But 15 is outside of our zone, so our critical numbers in this one are gonna be 3 and 9. Okay, so on my little number line, here I would label it, here's v of t, here's 0 starting, 12 stopping, 3, 9. By the way, this right here, this picture gets you absolutely no credit. This is scratch work for us, so we can say this is where it's negative.
That's here with the explaining part.
All right, we can use 0 and 12 because they're nice values. If we use 0, cosine of 0 is 1, that's positive. Stick in something like
Pi.
4 would be nice.
Pi. Oh.
No, pi is not bad, not nice. 4 would be nice because that reduces to 2 pi thirds. And cosine at 2 pi thirds is negative. Here, using 12 is actually fine because you get 2 pi, which is back to positive. So,
We could use 6, I thought.
yeah, 6 would have been good too. Anything that's going to reduce nicely would have been good.
That's what I meant by pi, is like.
Gotcha. When is it moving left? Okay, the particle
3, 2.
is moving left on the interval from 3 to 9
Parentheses.
because v of t
just remember that part.
What
That's
happened?
one that I do get right.
Points.
Yeah.
B
Points on that one, I think there were 2 points on this.
Yeah, there's one for the 0 and one for the answer.
Actually, it might have been 3.
But I missed
It might have been
Remember
one for
the
this,
writing
one for the critical numbers, and then one for your answer.
I didn't get that third point then.
Then it was only worth 2. I'm pretty sure it was only worth 2 then.
What's the grading say? That's my 4.
2 points. Considers V of t equals 0, so you didn't even have to get them correct, is basically this, and then your answer. They're finicky, year to year, they're just fickle with the way they assign points for this.
Okay, that's where I messed up, okay.
Write but do not evaluate an integral expression that gives the total distance traveled by the particle from time t0 to time 6. This is a joke of a problem, 0 to 6, absolute value,
I'm so upset.
v of t.
Oh, you didn't even have to write the cosine.
I wrote it.
I
I
did
still
too,
got
I
it on
almost
the
forgot.
Okay,
second.
if you have defined what v of t is somewhere, if you've said, oh, it's cosine, then fine, v of t, done, whatever.
I just-
Not the only way to do that. You could have also done this, from 0 to 3 of v of t,
From 3 to.
and then minus 3 to 6 of v of t. That's if you didn't want to use absolute values, but for those of you that didn't put absolute values, you forgot that it actually turned around in there,
Easy
and you
one.
needed to say
point.
that. Yeah, 1 point, done, that's it, so don't, anytime you see total distance, just bam, absolute value.
And it doesn't
Finish.
tell you to solve it, then you're like, shh. Well, if it actually solved, you couldn't do anything about
Yeah, we're good. We're gonna have to do that in part D, I think.
it. No, for B, you can't
The
solve it with that because
position
you
of
don't
the
have a
particle
calculator.
at t equals 4.
Well, we can take the antiderivative of that pretty easily.
But then we can't do that. All I'm saying is the absolute value doesn't.
No, we'd have to do this.
Yeah, that's what I'm saying. We
Right.
can't use the absolute value, wouldn't do anything because we're not using.
If they ask us to solve,
Yeah,
correct,
if they
yes.
ask. That's why we can actually do the absolute value.
Right. Find the acceleration of the particle. Is the speed of the particle increasing, decreasing? You people still don't get speed. What is wrong with you?
I do.
All right, acceleration.
What do we have repeated? Awesome. So
Okay.
we have the
So
derivative.
acceleration is the derivative of velocity. So and notice, I take the time to just put that down. You never know when it's worth a point, even if you can't take the derivative correctly.
Was that
at
a
least.
point?
I don't think so.
No.
No, one for actually finding A of t. So A of t
And then the reason.
is, but you get 2 points for the reason.
Yeah,
No.
2 points for reason.
Okay,
It's,
so
it's
derivative.
the reason.
Derivative of cosine is negative sine. Oopsie. And then we have to chain this so we get an extra pi 6. Some of y'all tacked it on to the end, which is perfectly fine, as long as you had it somewhere in the problem. Point. Now speed. 2 things to look at with speed, people. What are they?
Velocity and.
Velocity and acceleration. You have to look at both the velocity and the acceleration. If they are the same sign, you are speeding up. If they're different
Does that mean
signs, you are,
increasing and decreasing?
not really.
Okay.
Just speeding up, slowing down, that's different. So, here's my point. So now what I need to do is look at V of, what's my time? 4? Okay. I need to know what V of 4 is, and I need to know what A of 4 is.
Which one is position? Is that the velocity?
X. Position is the antiderivative of velocity.
Okay,
We haven't found that yet. We haven't done that. In part D, I think.
yeah.
All right, V of 4, here's V. All right, that is going to be the cosine of pi 6 times 4, okay, which is 2 pi thirds. Is that right? 2 pi,
Yes.
that would be negative 1/2.
Yeah.
Okay. Acceleration is going to be negative pi 6 times the sine of pi 6 times 4. All right.
At that point, I know that the sign of that is automatically going positive and the negative front.
And you know, they don't care about the answer as long as you just say, I know it's negative, yeah. This is 2 pi thirds, sine of 2 pi thirds is root of 3 over 2. Root of 3 over 2 times negative pi 6 is 3 over 2 negative pi root of 3 over 12. Whatever it is negative. Okay? So the particle is speeding up. Because, at
That's usually
equals 4, because
both VFT and AFT are negative.
VOT and AOT are both negative.
That reasoning probably would have confused me.
Think about it as multiplying two numbers together, two
Let's
negative
say, but
numbers.
if I just, if it's like.
By the way, not only is it speeding up, it is speeding up in reverse. It's actually heading backwards, or
Really
down, or
fast.
whichever way it's going.
Yeah.
It's on the x-axis, yeah, so it's heading backwards.
Fast.
Not that fast.
Faster.
D, find the position of the particle at t equals 4. Man, do y'all love to screw these up.
I
Yep.
didn't get my,
Okay, how do we do position?
wait, you want?
Anti-derivative.
Antiderivatives. Here's the dealio. Position is not distance traveled, so position would just be antiderivative of v, period. And if it comes out to be 0, that just means I ended up right back where I started. I may have traveled 1,000 units, but I ended up right back where I started. So I'm going to do this. I'm going to do the antiderivative. My position, which they've called x, my x of 4 is going to be the antiderivative from 0 to 4 of v of t. Mostly. Okay, why did I start at 0? I know the 4 makes sense. Why did I start at 0 and why do I have a giant gap there?
I mean, we have a giant gap here. Oh, because,
Okay, what exactly would this tell you?
Because it
What-
starts at time 0.
Good. What exactly, it starts at time 0, so that's good. I'm gonna now calculate everything from 0 to 4. So when I do this, it's gonna give me the change from time 0 to time 4.
so we're ended.
Not where it ended, per se, where it ended in relation to where it started.
Yeah.
Okay? So if I get this answer and it turns out to be 2, that means I ended up 2 units right of where I started.
Which is 0, so.
Right, so what we now have to consider is, where did you start?
Which is where I got one.
Where did you start? At time 0, where are we starting?
Negative 2.
That's where I started, and then this is the change from that.
That's my 4.
Does that make sense?